Okay, here we are at class 9, other types of equations. Okay, here we are at class 13. Let's start by doing some of these preview exercises together. If we want to find f of 0, that means that number in parentheses is always going to indicate an x value. So we want to look along the x-axis for an x value of 0, which is going to happen right here, and then go up to the graph, and the y-coordinate at that point is 3. So f of 0 is 3. For what values of x does f of x equal 0? So in this case, they're asking you for the x-coordinate, because that number in parentheses is what we don't know. And they've given us that the y-coordinate is 0. So y-coordinate of 0 happens along this horizontal line, and there are 2 points on the graph that have y-coordinates of 0. So that happens when x is -3 and 2. We call -3 and 2 zeros of the function, since they are x values that make f of x equal to 0. The real zeros are what we have up until now called x-intercepts. Okay, moving on to our demo. We're first going to talk about identifying the domain and range from a function's graph. So if you remember, the domain is the set of all inputs of a function, and the range of a function is the set of all of its outputs. So that is, the domain is all the x values and the range is all the y values. So we've got this picture of a graph of f of x, that's this blue graph right here, right? And all of these x values that the graph lives on, those are the domain of the function. And all of these y values where the function lives represent the range. So let's find the domain and range of this function graphed below. To find the domain, we look along the x-axis to find inputs that correspond to points on the graph. So we're going to use interval notation to represent this. So it looks like from here, all of these x values have points that live on the graph. And it just keeps going forever because of this arrow right there, that graph just keeps going to the right and up forever. So my domain, the x values that live on my graph, starts at -7, including -7, because there's a closed circle on that point, -7, 6. And then all of those x values until infinity. And remember, we never include infinity in an interval. Okay, so to find the range, we look along the y-axis and find outputs that correspond to points on the graph. So the lowest point on this graph looks like the -3, -2. So if we're looking at y-coordinates, then the smallest one is at -2. And then all of the y-coordinates that are bigger, there is a point on the graph that has that y-coordinate. So it looks like my range starts at -2, so I'm only giving y-coordinates for the range, and going up to infinity. And I should include the -2 because that -3, -2 is actually on the graph. Okay, the next thing we're going to discuss are even and odd functions. These are just names for functions that have special properties. An even function is a function that has symmetry about the y-axis. So that means that algebraically, if you plug in a number x and you plug in the opposite number, -x, then you get the same y value. So here in my picture, I have an even function. You can identify its symmetry just by glancing at its graph. It does look like if I folded it over the y-axis, the two halves would look identical. But an important thing to notice is that algebraically, when you plug in a value of 2.5 and when you plug in a value of -2.5, you get the exact same y value. They both give you -14.44 as a y value. So algebraically, that's what gives you the y-axis symmetry, is that a positive x and a negative x give you the same y value. Alternatively, an odd function is symmetric about the origin. So that means that if you folded it over the x-axis and the y-axis, the two sides would look similar. or not similar, but exactly the same. And algebraically, we can see this is that if you plug in an x and a negative x, you don't get the same y value anymore. You actually get opposite valued y's. So if we look at this picture, graphically, we can see that if we folded the graph twice, once over the x-axis and then again over the y-axis, then this piece of the graph and this piece of the graph would lie right on top of each other. Okay, but algebraically, the way we see this symmetry is that when you plug in opposite x values, so if you plug in positive 1.28 and negative 1.28, we no longer get the same y value like we did with even symmetry, but we get opposite y values. So when I plugged in 1.28, my y value is 12.13. And when I plug in negative 1.28, my y value is negative 12.13. So these two y values aren't the same, they are exact opposites. So in conclusion, for even functions, we see that opposite x values give the same y value. So that is, when you plug in an x and a negative x, you get the same y. For an odd function, you see that opposite x values give opposite y values. So that's it for today's demo. Get started on the class activities. The answers appear afterwards as usual. Please let me know if you have any questions.